Hello everyone, this is Tanya. I'm one of the TAs assigned to the Aircraft Stability and Control course taught by Professor A.K. Ghosh. We will be going through the concepts discussed in the previous week and discussing the assignment questions of the previous week. So just a brief overview of the past few lectures. What is control? Control of an aircraft, of pitching moment control, is to trim the aircraft at different CLs. So what is trim? Trim is when the summation of forces and moments is zero. And if we wish to fly it at a different speed, if we wish to trim the aircraft at a different speed, we require a different CL. And that would require deflecting the control surface. The control surface, as far as longitudinal angular motion is concerned, is the elevator. So the control surface elevator, deflection of the elevator, allows you to trim the aircraft at different velocities. That means at different CLs. So what this does is the CM versus CL graph. So it allows you to trim the aircraft at different CL. So this is where the CM is 0. This is where it is currently trimmed. Now, if you wish to trim the aircraft at a different CL, suppose at this CL, then you need to translate this. You need to move this line such that it can be trimmed at the new CL. Okay. So the deflection of the control surface translates your CM versus CL graph, the line. It does not change the angle. It does not rotate the graph. So it does not change the slope, right? It only changes the intercept. Only CM naught is changed. The slope remains constant. Few conventions: elevator down, that is the deflection of the control surface, elevator at the horizontal tail, deflection down is considered positive, because it produces a pitch down. It's a positive restoring moment. Okay, it produces a positive restoring moment, so it is considered positive. Elevator down is considered positive. Two interpretations of seeing how the elevator deflection works is we can interpret it as the zero lift line changes. That is, you get, when you deflect the elevator, the horizontal tail usually is a symmetrical airfoil cross section, and you have no lift at zero angle of attack. But when you deflect the elevator down, so this is your horizontal tail, and when you deflect the elevator down, you get a lift. So there is a lift produced here, delta L, even at zero angle of attack. So even if it is zero angle of attack experienced at the tail, it produces some lift. That is one way to interpret how the elevator works. The other way is, again, similar to the previous one, where you have lift at zero angle of attack. Which other airfoil do you have for that produces lift at zero angle of attack? A cambered airfoil. So the deflection of elevator is analogous to changing the camber of the airfoil. Okay, so that again produces lift at zero angle of attack. These are two interpretations to see how the elevator deflection works. Now, these are few formulas that we have been going through the last couple of lectures. CL delta E, this is the equation, CL delta E due to the deflection of elevator, okay? The coefficient of lift due to the deflection of elevator. This is a positive quantity because every entity in this equation is positive. The efficiency is positive, the areas are positive, tau, the control surface effectiveness parameter is positive, and CL alpha T is positive. So the lift curve slope of the tail is positive. So this entire term is positive. Now CM delta E, the pitching moment coefficient, the slope of the CM versus delta E graph is negative. Why? Because every other term in this equation is again positive and you have a negative sign associated with it. So you have a negative slope. Tau, like we discussed before, is the control surface effectiveness parameter, d delta dou delta alpha tail by dou delta E. And this is the equation for delta E trim, where this is, okay, you can write this as delta E trim is delta E naught plus d delta E by dCl into CL trim. Now this quantity, delta E naught, the intercept, is this one, CM naught and CM delta E. And it has a negative sign. So the overall sign of this term would be, can someone tell me? The intercept would be positive or negative? This delta E naught would be positive or negative for a stable aircraft. Assuming that you have taken CM naught positive, that is to trim the aircraft at a positive angle of attack, this entire d delta E naught would be positive or negative? Positive. Yes. So if we were to draw the graph, delta E and CL, your intercept would be positive. So delta E naught would be positive. What about the slope? This term, d delta E by dCl, this term, is it positive or negative? Cm delta E is negative. What is this term on the numerator? It's the static margin. For a stable aircraft, the static margin is positive or negative? Negative. So the entire term would be negative. The static margin is positive. Isn't that right? So this alone is positive. This entire thing would be negative. So your slope would be like this. Okay. So this is the delta E versus CL graph with a negative slope and a positive intercept. Now, as you can see in this graph, like we've discussed before, as the CG moves closer to the neutral point, the slope reduces and finally it becomes constant. It becomes zero. The slope becomes zero at the neutral point. So CG equal to neutral point. Okay, so this is done. Now, last lecture, we had discussed this question: to trim a flying wing at negative angle of attack, which of the following arrangements it's done? While explaining, I had made a mistake in this graph. This was the graph that I drew. This is wrong. Okay, so CM versus alpha graph does not have a positive slope. It has a negative slope. CM alpha should be negative for a stable aircraft, right? You remember this question last time? It's one of your assignment 1 or 2 questions. It's the question from one of the assignments, first or second one. Do you remember this question? Can someone just confirm if you remember the question? The answer that we had discussed was right, but the explanation was wrong because CM was, let me just take a different color. So this is what I had drawn previously. CM versus alpha graph does not have a positive slope. It has a negative slope. One of you should have corrected me. So CM naught is positive and this has a negative slope. Okay. So to trim a flying wing at negative angle of attack, which of the following arrangements is done? This is the wrong graph. So this is the correct graph. Can someone tell me now which would the right answer be? To trim it at a positive angle of attack, we need positive CM naught, right? So in this graph, where does trim occur? Can someone tell me at which point do you analyze the trim in this graph? Is it okay? This is point 1 and this is point 2. Which point is trim? At 2, exactly. So now we have a positive CM naught here in this graph. We have a positive CM naught in this graph and you are trimming it at this point, and that is a positive angle of attack. Now, if we need to trim the aircraft at a negative angle of attack, how should the graph look? How should the graph look? Will someone tell me? If we need to have this point at a negative angle of attack, if we need this point here, if we need to trim it at this point, what should we do to the graph? What should we do to this line? Graph would be displaced to the left. So what does that mean? When graph is displaced to the left, what does it mean? You move it like this. He's right. Graph is displaced to the left and you trim it at a negative angle of attack. So what does it mean? Negative intercept, right? So how do you get a negative intercept? Which of these points, which of these options gives you a negative intercept? Now this is CM naught and that is negative. Which of these options gives you negative CM naught? Exactly.
Aerofoil should be cambered.
Exactly, correct. So that was the option that we discussed, but the graphs were wrong. Okay, so this was wrong. I just wanted to discuss that. Now we'll move on to some from assignment 3. This is the question from your assignment 3.
Madam, just 1 minute.
Yeah.
1 minute. Hello?
Yeah, tell me, please tell me.
I want to ask some doubts in assignment 2, 3, and 4. So to whom shall I ask?
You can put it up on the forum, or assignment 3 I'll be discussing now. So if you can wait till then, maybe some of the doubts will be cleared.
Okay.
2, we had discussed all the questions in the last tutorial.
No. because some options are wrong actually. Means whatever answer is correct, but it is showing it is wrong. So one or two I will discuss with you.
Is it from assignment 3? Assignment 3 has a few mistakes. We'll be going through that.
Assignment 2. Assignment 2. Assignment 2 is having some mistakes. Consider in an aircraft. 1 minute.
Okay. If we have
which type of propeller
okay.
gives
This
less
assignment 2
longitudinal
questions.
stability? Which type of propeller configuration gives less longitudinal stability? Pusher type,
Yes.
tractor type, both option pusher and tractor type are correct and can't say. Actually, tractor type gives less longitudinal stability, but it is showing correct as a pusher type. So tractor type is correct one.
So for pusher type, where would the propeller be placed?
Pusher type is back.
So does that give more stability or less stability?
Pusher type will give more stability.
So what is the answer that is marked?
See, it is which type, question is which type of propeller gives less longitudinal stability? It should be tractor type, but it is they have considered as a this one pusher type. Pusher type gives more stability, but it is asking question is less longitudinal stability.
Okay, you can question up on the forum also. I will just get back to you. I'm not sure what was that.
And one more thing. With increasing horizontal tail volume ratio of the aeroplane, the elevator required for a given CL trim will be less is the answer, but it has correct answer. It is mentioned as a more. With increasing horizontal tail volume ratio of the aeroplane, the elevator required for given CL trim will be less. Less is the correct answer, but it is they have shown as a
no. We discussed this question in the last class. More is the correct answer.
Now, how, madam? Actually, with increasing horizontal tail volume ratio.
Can you please go back to the YouTube lecture that I have uploaded? We discussed this question in the last class. And if you have a doubt, you can put it up on the forum. But this question was discussed in detail in the last lecture, last tutorial.
Okay. One more thing. Two aircraft are geometrically similar, but first one is bigger in size and mass in compared with the second one, which is more stable. So actually, what I feel both the stability will be the same.
Okay. Again, this question was discussed in the last tutorial. Were you there for the last tutorial, or have you seen the video?
Last tutorial I was not there. Okay, I will see that one.
Yeah. Okay. All these questions were discussed there. If you still have any questions, we can discuss it either in the next tutorial or you can put it up on the forum.
Okay. Okay.
So for this question that you said, like geometrically similar aircraft, aircraft has larger mass. It's harder to disturb the aircraft from the position of stability, right? That is the explanation.
No, but if bigger means the mass will be also in proportion to bigger one. That also answer that one also meaning will come.
Yeah. So if it is heavier, it is harder to deviate the aircraft. It's harder to disturb the aircraft.
No. So consider a wind tunnel model and actual aircraft model. So if you consider like this one, then there will be hardly any difference from stability point of view. Otherwise, what is the point of conducting wind tunnel testing? Okay,
let me just get back to that. I'm not sure about that. But as far as I still think that it's harder to deviate a heavier aircraft. I mean, harder to disturb a heavier aircraft. Disturbances is what I feel.
No, but because I discussed with Professor A.K. Ghosh sir, so whatever I'm telling the answers now, he also told it's a correct one. Means whatever I'm saying, just telling, like this one, tractor type is having less stability. So his opinion is also same thing.
Okay, if he has said that, then maybe he would be considering it for the assignment evaluation. Let me get back to you, or you can put it up on the forum as well.
Oh, okay, madam. Okay. Okay.
Okay, so this is the first question of assignment 3. The data given to you is put up on the screen. We just go to the first question. So the first question is the pitching moment coefficient at 0 degree angle of attack for wing. We have done a similar question in the last lecture. So what would the formula be? How do we calculate this? Can anyone tell me? It's the intercept contribution of the wing. Cm naught contribution of the wing. Pitching moment coefficient at 0 degree angle of attack for wing. Okay, so this is the formula. And we'll try solving this now. Okay. So CMACW is minus 0.009. CL naught. How do you find out CL naught? Can someone tell me how we find out CL naught? We have done this in the previous similar question. So what we have, they've given us angle of attack at 0 lift. They've given you the lift curve slope. So how do you find out CL naught? Can someone tell me how you find out CL naught when the slope and the angle of attack at 0 lift is given to you?
It's a DCL by, it's a CL alpha W multiplied by minus of alpha at lift is equal to 0.
Yes, okay, so it's like the modulus of alpha at lift equal to 0. Okay.
Okay, modulus.
Huh?
Okay,
This is fine, right?
okay. Modulus. Okay.
Okay. So that's 0.09 into 2. How much would this value be? Right. So 0.18 and XCG, that would be 0.03. Okay, what would this value answer be? Can someone just calculate quickly? Someone's just, okay, so it's minus 0.0036. Are you all getting that? This is CL versus alpha. This is CL. Okay, is this fine? Okay. Next question. The pitch stability derivative of the wing, that is Cm alpha wing in per radian, will be. So the equation, the contribution of the wing towards the slope is given there. Again, we have all of these quantities. CL alpha of the wing. Okay, this should be CL alpha of the wing. Okay, that's 0.09. 0.03. That would be 0.0027, and this would be in per degree. To convert per radian, we multiply with 57.3. How much would this be? Someone just calculate quickly and tell me which is the correct option. In per radian. This is in per degree. Yes, 0.1546. 0.1546. Next question is the value of the downwash angle at 5 degree angle of attack. What will it be?
Hello?
Okay, so these are your, yes. Yes. No, okay. So what is the aspect ratio's formula? Aspect ratio of the wing. Can someone just tell me what is the formula for aspect ratio? Here we need to find out aspect ratio. What is the value? What is the formula for aspect ratio?
For this case, rectangular case, you can take as a B divided by C bar. B
Yes.
square by S actually is the formula, but B by C bar you can take it.
Correct. So it's B square by S and it's B by C in this case. B here is 26 and C is 2.2. And okay, right? So if you substitute those values here, CL naught, how much did we find CL naught as? 0.18, right? CL naught was 0.18, right? Yes. So pi and 26. 2.2. What is this value? And this again, we need to convert it into radians. So I mean, back that way. So what is this value? Just calculate quickly and tell me what is the value. 0.555. Slope 26. 2.2. Again, what is the value? Again, 57.3.
0.555.
That's epsilon naught, right?
Yes.
What about d epsilon by d alpha? What is d epsilon by d alpha, this value? Just calculate quickly. It's coming to 2778. Is that right? Okay. So now your overall downwash angle would be epsilon naught plus d epsilon by d alpha into alpha, correct? So it's 0.555 plus 0.2778 into 5. Is this correct? Is this correct?
1 minute. Hello.
Yes, yes.
That d epsilon by d alpha is in is it in radians? Whatever you have calculated?
So we've converted into degrees, right?
No. What you calculate 2 CL alpha divided by pi ER. That is in which this one you have calculated?
So it's the slope, right? So it should not have a unit.
Okay.
Okay. Both are angles.
No,
so
but you have multiplied there by, it seems that you have multiplied there by 57.3. Yes, we see there. You have multiplied by it.
So usually your CL alpha wings, we take it in per radians, right? The value is given in per degree. So we need to, for all these equations, we take it in radians.
No, you are
right?
taken in, what I'm saying, 2 CL alpha, it is, it does not have, it is a slope, but 2 CL alpha divided by pi EAR, if we do that one, if we don't multiply it by 57.3, okay. So straightforwardly, you multiplied by 5, see, it will come, see.
So this formula is valid only in radians. So that CL alpha wing has to be in per radians. Only then we can use that formula. Only then we get that d epsilon by d alpha. So the slope has no unit. I agree.
No, this one d epsilon by d alpha, you are saying it should be in radians. So that's what you have multiplied 57.3.
No. I mean, d epsilon by d alpha will not have a unit.
I agree. Well, 57.3, why you have multiplied?
Because your CL alpha wing is in per degrees. Are you able to see that?
No. What I'm saying, 2Cl alpha W divided by pi EAR.
Yes.
Okay. If we don't multiply it there by 57.3 and multiplied by 5, that itself is the answer. If you are multiplied by 57.3, then 5 divided by 57.3 should be there.
So
Okay.
this
If you are multiplying here 57.3, then here you should convert into radians 5. 5 divided by 57.3.
is valid only if you are radians, but you just have to ensure that this is also in degrees, right? Like,
see, this if you are taking into degrees, 2Cl alpha divided by pi EAR, straightforward it will come in degrees. Then multiplied by 5 is okay. But if you are here multiplying by 57.3
see, this term, this 0.2278 has no unit. It is just the slope.
What is the necessity of multiplying by 57.3?
Because your Cl alpha wing has to be in per radians. This formula is valid only if that is true. This formula has, like, while defining this, if we go back to the previous course, I believe sir has mentioned that the Cl alpha wing, the unit of this has to be in per radians. Right. I think all of those relations have to be in per radians. Only then would it be valid.
If Cl alpha W is in radians, the del
per radians.
In the radians.
Yes. So this relation that is there for d epsilon by d alpha, so the terms are only, they give you the slope only if that is in radians. Otherwise, it would not be the slope. It would not be unitless. I'm not sure if I'm able to convey it.
No. Then see, in epsilon 0, you multiplied by 57.3 to get in degrees, isn't it?
Yes.
But similarly, here also should be in degrees.
So, see, 0 has a unit. So this has to be degrees. I'm sorry about that. That has to be in degrees. Okay. Am I making sense? Like this term would give you radians, and then I would give you radians, and then to get a degree, we do this. So I can actually omit this step here and do that here, because your alpha is in degrees. Now, this term, this d epsilon by d alpha, is unitless, and that value will come only if this Cl alpha is in per radians. It will not be the same if it is in per degrees. This equation holds true only if it is in per radians. So this 57.3 is for that Cl alpha wing. This 57.3 change your radians to degrees. Is it making sense now? Is it making sense? Can I move ahead?
Just 1 minute. I will. One book.
Yes.
1 minute.
Yes. Does anyone else have any input towards this?
0.45. 1 minute, yes. And here, once epsilon 0 to here.
Can I please move ahead?
Point.
Can I please move ahead?
Okay,
we are losing time.
Okay.
Okay. Is it clear? Like, are you satisfied with the response?
Okay. Otherwise, I will talk with you regarding this one.
Okay.
Later.
Okay. Sure. Okay. So, does anyone else have any query regarding that part, or should we move ahead? I'm guessing not, so I'll move ahead. So can anyone tell me the final, what is the value here? Okay, sorry. What is the value here? Calculate it. Can someone just calculate this value quickly? 1.94. 1.944. This is the correct answer. I believe the assignment did not have this option, so it would be considered. I've already spoken with the authorities. They have a small typo here. This should have been the correct answer. Okay, so it's 1.944. Okay. Next question is the pitching moment coefficient at 0 degree angle of attack for the tail. So Cm naught contribution of the tail will be what? Again, we can write the formula Cm naught of tail. This is the formula. Now we need to calculate VH here. VH is the surface area of tail by surface area of wing into the this is the formula, right? So this is the moment arm of the tail. Now they've given you in the question that the surface area of tail is 1/4 that of the wing. So this value would be 1/4. And they've given that the distance between, what does the question say? Okay. So distance between the aerodynamic centers is equal to half of the wing. The wing and tail are rectangular in shape. Okay. So this LT is half of the wingspan. So LT is B/2. And C. So this would be 1/4 into 26/2 into 2.2. What is this value? 1.477. Okay, is this fine? I'm going to use that value here. So VH is 1.477. Tail efficiency is 0.89. CL alpha of tail is 0.59, 0.059, sorry, into these components, 1.3. Epsilon naught was what? What was the value for epsilon naught? Previous question, 0.555 plus 1.3. Right, so what would this value be? Can someone calculate quickly? Just calculate this value. 1.3 plus 0.55 plus, come on, fast. Is that the value? I don't think that is the value. That is the option that is given there, but what is the value? Just calculate it. 0.2446. Is that okay? Okay. So again, the options are wrong in these questions. We'll discuss that later, but we'll just go with the values that we are getting. Okay. We'll just solve the question. The options are wrong. Some of them are wrong. I'm not sure which ones. So we'll just go ahead with this. Is that fine? This is the value that I'm getting as well. Okay, so I'm going to go ahead. The pitch stability derivative of the tail. So the tail contribution towards the slope of the graph in per radian. So Cm alpha tail, this is the value. We have VH value. What was VH value? 1.477 into 0.89 into CL alpha tail. One minus what was, how much is dou epsilon by dou alpha? It's just this much. Okay, that is the slope. How much is dou epsilon by dou alpha? We just calculated it in the previous question. How much was it? Am I audible? Can all of you hear me? Can someone confirm if you can hear me? Okay, so what was the value of dou epsilon by dou alpha that we calculated? It was 0.2778. Now, can someone just tell me the final value here? Cm alpha tail. Just multiply these things fast. And this would give you a value in per degree. Okay, so now we need to convert it to per radian after this. So what is the value in per degree? Just calculate this value fast. Just multiplication. So it gives you minus 0.00056 per degree. And that would be into 0.321. So you multiply 57.3 to it to get it in per radian. And you get, how much was the value? Minus 3.2. 3.21 per radian. Okay, so that is the correct value here. Next question. If the fuselage contribution to Cm alpha is equal to 0.99 per radian, the difference between neutral point and aerodynamic center of the aircraft in meter will be. So now we know this formula. So we know the difference between x neutral point and x AC of the wing. This was written by Sir in one of the lectures. And we know the contribution of tail. So this is the contribution of tail towards this equation. In similar terms, we can add the contribution of fuselage towards this equation. Okay. So now again, x bar np would be 20 minus x bar s. So can you just tell me the values? Just tell me the values. VH was how much? Horizontal tail volume ratio was how much? We just calculated it. How much is the value? Okay. 1.477. The efficiency factor is 0.89. CL alpha of tail is 0.059. CL alpha of the wing is 0.09 into 1 minus. How much is that value? 0.277. Right? That was that. Minus CL alpha of the wing of the fuselage. CM alpha of the CM alpha. This equation is wrong here. It should be CM alpha of the fuselage. Okay. No mistake. CM alpha. CM alpha of the fuselage is 0.99 and CL alpha of the wing is 0.09, and that is in per degrees. Okay, so this value is in per degrees. We need to change that. So you multiply the denominator with 7.3. Is this clear? Okay, so this 0.99 is in per radians, and this is in per degrees. So we multiply the denominator with 57.3 to convert it into per radians. Is this clear? Can someone just confirm if it's clear or if anyone has any doubt in this? Is it clear? Okay, so I'm going to assume it's clear. Okay, thank you. So it's clear, and this value would be, so x bar np minus x bar AC wing would be, what is this entity? 0.622 minus 0.1919. So now they've asked you to find the difference between the neutral point and aerodynamic center. So this is basically XNP minus XAC wing by C bar is equal to this value. How much is this value? 0.43056. So now you're, so XNP minus XAC would be 0.43 into C bar. So that is 0.43 into how much C bar? 2.2. This value is 0.947 meters, right? Were you able to follow this question? There's a mistake in this equation here. It's a CM alpha of fuselage and divided by CL alpha of the wing. So it's a CM alpha of the fuselage. Is it clear now? Is this question clear? Okay, since nobody's asked any questions, I'm going to go to the next one. This is the next question in your assignment 3. The pitching moment coefficient versus angle of attack for a large jet transport aircraft can be seen in the figure below. Use the table along with these two equations, CL and CM, where CL is the lift coefficient of the complete airplane and alpha is in degrees. And they've given you XCG location. First question is elevator control power in per degree will be. And we discussed this in the previous class, a similar question. How do you start? What is elevator control power? What is the term? Elevator control power, what is the term? What is the term that we need to find out? When they say elevator control power, what are we calculating? How do you represent elevator control power? What is the term that we are calculating? What is the entity? What is it called? What is elevator control power? Someone please tell me.
dCm by d delta.
Yeah, CM delta, correct. One second. CM delta E. In this case would be what? So you just find the slope of the line, which is 0.031 minus 0.016 by minus 8.5 minus 1.3. So all values are in degrees, so you can just find it in per degrees. What is this value? What is the numerical value? Just find the values, just subtract these and divide it. Which is the correct answer? Which is the correct answer here? So it's minus 0.0015 per degrees. Per degrees. Right, so that is this. Next question is stick fixed neutral point will be. How do you find this? So we have this equation, static margin dCm by dCl is the stick fixed. How do you find this? Okay, so static margin is this value, is minus dCm. You can say dCm by d alpha into 1 by dCl by d alpha. Okay, can we say this? Is this same as this? Right, so there's just division of two slopes. So what is Cm alpha in, from the equation that was given? The Cm equal to 0.03 minus 0.002 alpha. What is Cm alpha? What is this? This is basically Cm alpha by Cl alpha. So what are the values? What is Cm alpha from this equation? So this is the equation. What is Cm alpha? Minus 0.02, correct. Minus 0.02, and CL alpha similarly would be 0.08, right? So what is this value? 25. Now they've asked, we know this value, xcg by c bar we know, we need to find out xnp. So x bar np by minus x bar cg is equal to 0.25. Okay, so now x bar np is 0.25 plus 0.5. Is this clear? Is this clear? Is this question clear? Yes. Thank you for confirming. Next question is the zero angle elevator trim. So delta E naught in degrees. How do you find this? It's the intercept. Delta E naught, we know the formula. Now what is Cm naught from the equation? From this equation, what is Cm naught? What is Cm naught from that equation? 0.03, yes. 0.03. Cm delta E we found out as minus 0.0015. How much is this value? 20 degrees. So delta E naught is 20 degrees. Yes? Delta E naught is positive, we know that. And it's 20 degrees here. Okay? The aft center of gravity limit for xcg will be. So what does this mean? Most aft limit for xcg. So we know that for a stable aircraft, your CG should be ahead of neutral point, right? So the aftmost point for CG would be neutral point. Exactly. She's right. So aftmost point for CG would be neutral point. So the answer here would be the neutral point location, which is what we calculated to be 0.5, right? It's the same thing as neutral point. So is assignment 3 clear to everyone? Any questions from assignment 3? Okay. Now we move to week 4 content. So I'm just going to go over a few concepts that Sir discussed. Delta E trim, the equation that we know from the previous lectures, it's the same. So this is the intercept and this is the slope, positive intercept, negative slope. Then Sir discussed the cruise, steady climb and landing configurations. For cruise, we have lift equal to weight. For steady climb, these are the equations. These are the same equations from your airplane performance course. Now, while landing, there is a reduction in downwash due to your ground effect. So there's a reduction in the downwash angle. So what happens is that there's a delta, the change in the effective angle of attack at the tail. So due to that, you need to deflect your elevator more such that you're able to trim it at the same value. Okay. So this is the delta E that compensates the reduction in the angle of attack at the tail during landing. So this is what Sir mentioned as we keep a margin. This is the margin that we keep from your maximum deflectable elevator deflection. So if your delta E max is 20 degrees and this is say 5 degrees, so your maximum deflection in flight would only be 15, because while landing you need an extra 5 degrees and you need to have that contingency. And few conditions that Sir discussed were minimum thrust required and maximum power available. So minimum thrust required amounts to L by D max. The ratio between lift and drag should be maximum. That is when we get the minimum thrust required. And the lift coefficient for such a condition is given by square root of CD naught by K. Similarly, for maximum power available, the condition is the rate of climb is maximum. Rate of climb is given by this equation and the maximum power available would be the maximum here. And the CL analogous to this condition would be CD naught. Okay, this is wrong. This is wrong. Okay, so leave that. So these are the conditions discussed in the lectures. Next, we discussed a couple of maneuvers, pull-up maneuver and steady coordinated turn. both of these conditions, lift is greater than the weight, and the ratio is given by n. And we've discussed the pitch rate for both of these maneuvers. Pitch rate is g by v into n minus 1 for pull up. For a steady coordinated turn, it's this value, n minus 1 by n. Now, when you deflect the elevator, so when you pull up, so when the aircraft is pulling up, like sir mentioned, there is an additional at the tail. So if this is the tail during pull up, there is an additional lift generated, which contributes towards stability. There's an additional lift that's generated at the tail that contributes towards stability, but we need to maneuver the aircraft. What happens if we don't, if we contribute to stability, what happens is when you pull up, it will tend to restore that movement. It will tend to go back to your trim condition. So in order to trim the aircraft for during a maneuver, you need to deflect your elevator. How much we deflect the elevator, the additional deflection of elevator to trim the aircraft in a maneuver is given by this value. And now here, this Q changes for pull up and steady coordinated turn, which we know as this and this value. Now the overall delta E trim, delta E deflection of elevator to trim the aircraft is given by this entire equation. The first two terms we have already discussed in the previous equations, the intercept, the slope and CL trim. This is the additional term that has come into play during a maneuver. So you need an additional elevator deflection during a maneuver to ensure that the stability doesn't hinder the maneuverability. Now here, this delta E naught, which is calculated over here, delta E is put over here, and this Q changes for each of the maneuvers. For pull up, it is this, and for steady coordinated turn, it is this. Now, just a few questions. This was discussed by sir in the class again. For a steady climb, which of the following is correct? Is the lift coefficient in climb lesser than the cruise, equal to cruise, or greater than the cruise? The lift coefficient during climb, is it lesser than or greater than the lift coefficient in cruise, or is it equal? The coefficient of lift during climb, the relation between the two coefficients of lift, CL during climb and CL during cruise. This is one of the first points discussed by sir when he discussed climb. Climb is less than cruise, exactly. So sir had mentioned that the induced drag for cruise is greater than the induced drag for lift, for climb. So that's the same reason. This is the correct option. Now, just now we discussed the pitch rate Q for a steady coordinated turn. We just discussed this thing. Steady coordinated turn is G by V, N minus 1 by N. So that's the first one. Right? So this is the one. Next, what is the delta E required to trim the aircraft with a static margin of 10% given CL trim, delta E naught and CM delta E? Can you do this question? This doesn't involve any of the maneuver components to calculate the delta E required. This question, we know the standard equation for delta E trim. Okay, so this is your delta E naught plus, this is the static margin, CM delta E and CL trim. Okay, so delta E naught is given to you as 0.05. Static margin is 10%. CM delta E is -1 and CL trim is 0.2. This is fairly straightforward. What is the answer here? What is the answer here? How much is the delta E required to trim the aircraft with that CL trim? 0.03. Okay. So maneuvering point is defined as the CG location where. How do you define maneuvering point? Just like we define neutral point location as the location where there's no change in the, so DCM by DCL is how we define neutral point, right? So it's the CG location. Here, what is the maneuvering point? How is it defined? What entity is 0? Maneuvering point? How do you define maneuvering point? Is it d delta E by dCl or d delta E by dN or d delta E by dCm or d delta E by dCd? How do you define maneuvering point? It's just how the maneuvering point is defined. It's the point at which
d delta E by dN is equal to 0.
Yes, correct. This is the correct value. Now this is the question. In a flight test, following data was obtained while trimming the airplane at different speeds. Okay, so they've given you the speed, angle of attack, CL, elevator deflection, and CG location for different trim conditions in flight results. And the lift curve slope is also given to you. So the first question is, what is the value of stick fixed neutral point? Can someone tell me how we'll proceed with this question? So you have 4 sets of readings, 4 sets of speed, angle of attack, CL, elevator deflection, and CG location. They've asked you to find out neutral point location. Can someone tell me how we'll proceed with this? Okay, so we know this equation. Delta E trim is delta E naught. This equation that we just used in the previous question. So now we'll just take a few values and see how this equation looks. We'll take the first one. Delta E trim for the first case is 3. Delta E naught, we don't know. Plus X bar NP, we don't know. Okay. X bar CG is 0.3. Just a minute. Let's grab some water. Sorry about that. Okay, so CM delta E, we don't know. And CL trim for the first case. I'm just taking the first case, okay? This is the first value. So the CL trim there would be 0.5. Now we take the next values. So there the delta E trim is, what is the next delta E trim? For the next set of values, what is delta E trim? Oh, here it says 3 degrees up. So this would be -3, okay? Sorry for that. For the next set of values, what would be delta E trim? So for the first set of values, the delta E trim was here, right? So this is 3 degrees up. So that is -3. So in this case, in the next set, what is your delta E trim? +1, exactly. Okay. So 1 equal to delta E naught plus X bar NP minus what is X bar CG in this case? Again, it's 0.3. CM delta E. And what is CL trim? What is CL trim for the second case? What is CL trim for the second case? Okay. So now we solve these two equations. You subtract these two equations. You subtract these equations and you get a relationship between XNP and CM delta E, right? Am I right? Can we do that? Am I right? So I'm just going to go ahead and do this. -3 minus 4. This would go. And you would have X. Have minus X bar NP minus 0.3. Right? Minus X bar minus 0.3. CM delta E into 0.5 minus, sorry. Just a second. Okay. Just a second, sorry for the delay. So it will be plus minus 0.3. Okay, is this okay? So you would get your x and p in terms of Cm delta E, x bar and p as 0.3 minus 20 Cm delta E. Okay, let's just keep that there. Similarly, we perform the same iterations for the next two sets of equations, next two sets of values. So what would be the value for the third? For the third set, what is delta E trim? Is 0, right? 0 equal to delta E naught plus x bar NP minus x bar CG is 0.4 Cm delta E, right? And CL trim is 0.4. Then it's 1.5 down, so that is positive, is equal to delta E naught plus x bar NP minus 0.4 by Cm delta E into 0.1. Similarly, we subtract the bottom equation from the above equation and we get a similar relation. I'm just going to write the final relation. X bar NP is 0.4 minus 5 Cm delta E. Okay. Okay, is it clear till now? Are you following me? Does anyone have any doubt till now? So what we did is we took this equation and plugged in the four values, four sets of data. First we did for the first two. So this is measurement 1, this is measurement 2, this is measurement 3, and this is measurement 4. So for the first two sets of values, we plugged in the values, we manipulated it and got XNP in terms of Cm delta E. Similarly, we did that for sets of measurements 3 and 4, and we got another equation of XNP in terms of Cm delta E. Now we can use these two equations to solve for x bar and p, right? Can we do it? Can someone calculate the x bar and p value here? So from here you get Cm delta E as what? X bar and p minus 0.3 by minus 20. Similarly, from the other case, you get a Cm delta E as 0.4 minus x bar NP by 5. So x bar NP is this making sense? Is anyone confused? Does anyone have any questions? Okay, I'm guessing not. Solving this will give you your XNP value. XNP here in this case is 0.433. Okay. So what we did is we plugged in the first set of values, second set of values, got two equations, solved them and got an equation for XNP in terms of Cm delta E. Then we plugged in the third and fourth set of values, manipulated the equation, got an equation in terms of XNP and Cm delta E. We used these two equations to solve for x bar NP. That's how we got x bar NP as 0.433. Okay. Next, most aft CG locations such that the aircraft has minimum stability margin of 5%. This is simple, right? Stability margin is given to you and we need to find the most aft. You have x bar NP. So stability margin is 0.05. X bar NP is 0.433. Now x bar CG. So what is the x bar CG? What are they asked you to find out? X bar CG. How much is that value? We just do that calculation. What is the value? What is the value? Just subtract this. Okay, you should be able to do it from here. I'm not going to do it. Similarly, next question says, if you take a minimum stability margin of 10%. So again, you have 0.1 and stability margin is x bar NP minus x bar Cg. So you have 0.1 is equal to 0.433 minus x bar Cg. From here, you will be able to find out x bar Cg. Okay. So with this, we finished the lecture for today. Did anyone have any other questions? Can we end the lecture?
Nick, can you tell us your email address so that we can send any question is there?
You can put it up on the forum. We can respond there.
Okay. Regarding assignment number 2, now I am having some doubts, sir. So that's what.
Yeah, you can put it up on the forum. All the TAs will have access to that, so we can respond there.
Okay.
I'll just send you my email ID just in case, but please do use the forum as well. Okay.
Yes, yes.
Yeah,
if you can send that detailed, I can send it. So that's what.
Yeah.
If you can tell us.
I'm just writing it.
Yeah.
Okay, here it is.
1 minute.
Yeah.
No. Can you show the email address?
Yeah, I have put it up in the chat box.
No.
I have sent a message in the chat box just now.
No, sorry.
Can you see it?
Sorry?
Did you get the email address?
No.
I just sent it to everyone in the chat box. Okay, meanwhile, I'll just share the YouTube link as well. Please do go see the previous lecture. So I think some of the doubts at least should be clear.
Just tell your address. TAN, email address.
TANYAKK20.
TANYA. KK.
KK20 at IITK.ac.in.
Okay. TANYAKK20@IITK.ac.in.
Yes, that's the one.
Okay. Thank you very much.
Yeah. Any other questions? You can put it up in the forum. Okay. All will be able to respond.
Yes. Okay.
So if there are no further questions, I think we can end this here. I have shared the link for the YouTube lecture, previous tutorial lecture. So you can go through that. I think at least few of the doubts will be clear.
Okay.
So if there are no other questions, then have a nice day. We'll meet again next week.
Okay. Thank you.
Thank you.
Thank you.